What's up, mathematics? Welcome to another episode of Mathtastic. Today we're going to look at multiplying and dividing with integers. That means both negative and positive numbers. Oh my gosh, how does that work? I'll tell you in a second. This is probably our last new content on integer operations, and our next series of videos is going to be about order of operations. So get excited! I know you're just bursting at the seams to get into order of operations. Here we go. Let's talk about, we'll talk multiplying first, and then we'll get into division. I think what's tricky about multiplying is not so much the rules around negative and positive numbers. What's confusing about that is that they're different than the rules around addition and subtraction, but as long as you can keep them separate in your mind, you're okay. But the notation gets a little funky on us at this point in mathematics. We're used to seeing multiplication done like this, vertically, with an x to indicate the operation of multiplication. 3 multiplied by 4 is 12. More recently, maybe you've been seeing it horizontally. 3 multiplied by 4 is 12. We're going to drop the x now. It no longer is going to represent multiplication, and we're going to start to use some other symbols when you're meant to be multiplying. The reason for that is in algebra, x is going to stand for an unknown number or a number that varies inside of an expression or an equation. So it becomes this unknown thing, which is very important to algebra. It's kind of at the heart of what algebra is. So we need to come up with a different way to tell whoever's reading our math equation to multiply, because the x becomes too confusing. So one of the things that you'll start to see is this dot. When you see a dot that's in the center of the number, so I'm going to write 3.4 down below here. This is a integer portion and a decimal portion of a number. That's what the dot represents. But if you see it raised up just a little bit so that it's in the middle, it means to multiply. This is 3 times 4, or 12. But even that isn't super common anymore. What's really going to move into is using parentheses to indicate multiplication. So it's going to start looking like this: 3 times 4. Whenever you see a number or an unknown, like a letter, adjacent, by adjacent, I mean right next to a parentheses like this, it means to multiply, and it can be on either side. Both of these things mean 3 times 4, or in the case of the second one, 4 times 3, but it doesn't matter because you can switch things around in multiplication. This also means to multiply if there's a parentheses right next to a parentheses. Got it? Why do we do that? It is helpful when we start dealing with negative numbers, because the subtraction sign and the addition sign are still the subtraction sign and the addition sign. So what's the difference between this and this? Actually, I'm going to change this to a positive so that we know. Well, here we have parentheses around the -4, but there's an operator between the other number. We have 3 addition -4. This is 3 plus a -4. On this example, there is no operator between the number and the parentheses. This one here is multiplication. It's -12. We don't know the rules to multiplication yet, so you're not expected to know -12. You will in like 2 minutes. Okay. So over time, you're going to get used to the use of parentheses. This is just a little bit of a primer into that. Let's use parentheses to practice now what the rules of multiplication are. And a little hint, the rules of division are exactly the same. Let's go -3 times a +4. We'll start off with the easy one. And then I'm going to put both of these in parentheses so we can practice and get used to what parentheses look like. I'm going to tell you the answers. 3 times 4, this is what it's always been, 12. In fact, all of these are 12, but some of the 12s are negative and some of them are positive. 3 times a negative 4, negative 12. Negative 3 times a positive 4, negative 12. Same thing. Negative 3 times a negative 4, positive 12. So here are the rules. If there is one negative and one positive, the product is negative. One negative, one positive, the product is negative. We'll get into what to do when there's multiple factors in a second. The second part of the rule is if it's a negative and a negative, it's a positive. Now, why is that? I don't really know. I find it really confusing to figure out the sort of intuitive reasoning behind this. It makes more sense when you get into graphing because it makes pretty pictures if you follow these rules, or pictures that make sense. But let's think of it this way. If we think of a negative 5 as the opposite of positive 5, so here's 5, opposite of negative 5. Here, we have 3 times 4 opposite, right? So 12, but here's the little phrase that says opposite. So that brings us, let's come up with a number that, let's say 5 times negative 1. So 5 times the opposite of negative 1. So we have 5, 1, and an opposite. That brings us negative 5. Now, if I say negative 5 again, I have 5, 1, that's 5, opposite, opposite. What's opposite, opposite? Well, what's the opposite of up? Down. What's the opposite of the opposite of up? Well, the opposite of up is down, so the opposite of that is up again. So the opposite of up is up. I told you it was crazy, right? So if I'm looking at 5 and I say, well, what's the opposite of 5? It's negative 5. But what's the opposite of negative 5? It's positive 5 again. For that reason, if you're following me so far, negative 3 times negative 4 is a positive 12. A negative times a negative is always a positive. So as a quick reminder, these are not the rules of addition and subtraction. Addition, we have to look for which number has the greater absolute value. We subtract, we give the sign of the number with the greater absolute value to the sum, right? That's when the signs are different. If the signs are the same, we look at whatever the two numbers sign is, and we give that sign to the sum. The rules of multiplication are and division are different. 2 negatives gives us a positive. 1 negative, 1 positive gives us a negative. All right. We don't care that the 4 has a greater absolute value than the 3, or the 3 has a lesser absolute value than the 4. 1 negative, 1 positive gives us a negative. Okay. So I promise I would talk a little bit about what to do if we had multiple numbers. So in this case, we have 3 numbers that we're multiplying together, and they're all negative. Let's do it one by one. Negative 1 times a negative 2 is a positive 2, but we still have this negative 3. Negative 2 times a negative 3 is negative. Positive 2 times a negative 3 is a negative 6. So 3 negatives is going to give you a negative. It's the opposite of the opposite of the opposite of, which lands you on the negative side. But what if there was a fourth one here? I'm going to bring in a negative, I don't know, 6. Let's get crazy. Let's see if I can remember my multiplication tables here. Negative 1 times a negative 2 is a positive 2. We still have a 3. We still have a 6, both of which are negative. Positive 2 times a negative 3 is a negative 6. But we still have a negative 6. A negative 6 times a negative 6 is a positive 36. So if you can remember this, even numbers, occurrence of negative numbers will always give you a positive product. How many occurrences of negative numbers do I have in this example here? 1, 2, 3, 4. 4 is an even number, like 0 is an even number. Odd occurrences of negative numbers will always give you a negative product. Okay, division works exactly the same way. So don't freak out with division. Really quick, let's say 6 divided by -3. We have one positive, one negative. That's going to give me a negative quotient, -2. What's important to know about algebra is we start to phase out this division sign a little bit, and we go to the fraction sign instead. 6 divided by -3 is -2. Oftentimes, though, a test writer or someone who's writing mathematics might write this quotient as 6/3 with the negative sign in the middle, which tells you either the 6 or the 3 was at one point negative, but whoever's writing the math knew that it would make the whole thing negative, so it just stuck it right in the middle. -2. All right. Okay. That was fast and furious. And we'll do one more to recap everything before we move into order of operations. Great work. Keep at it. This is only meant to support you in the other work that you're doing. So I hope you're getting something out of it. And Mr. Mike out for now.